Today we are going to continue with the rest of chapter 2. So before we proceed with the rest of chapter 2, let's recall back what have we learned in our previous class. So in our previous class, I have highlighted the importance of data model. Simply we can say it as a communication tool among designer, stakeholder, and end user. Okay, then what else? We have seen also 4 elements in basic building blocks, which are entity, attribute, relationship, and constraint. So I hope by now you are already clear about these 4 elements. And also we have seen a few types of data model: hierarchical, network model, relational model, and the last part that we have covered is entity relationship diagram. Okay, so and also I have given you the exercises related to ERD. Okay. Okay, this is the last part that we have covered previously. Okay, we have 2 approaches to draw the ERD: chain notation and cross-foot notation. Okay, by now I hope everybody is clear about the drawing, how to draw. Okay, so today we are going to continue with the rest of chapter 2. Okay, let's look at this one. This is 3 different approach to draw the ER model. Okay, or we call it as notation. So the first one and the second one I have introduced to you previously: chain notation and cross-foot notation. And on your right is UML class diagram notation. Okay, so we have 2 entities, painter and painting. Always remember it should be in singular. Okay, bila you buat you nak tulis nama entity, pastikan tak perlulah tambah painters, painting. Dia mesti dalam singular. Okay, that is the rule. And then what can you see here? You have 2 entities and their relationship is one to many. Okay, that's how they represent using UML. UML stands for Unified Modeling Language. Okay, this is the connectivity. Means one painter, one painting is painted by one painter. Okay, and then this one painter can paint many paintings. Okay, then the relationship here, paints, and this one at the painting side, painted by. Okay, second one, we have employee and skill. This one is many to many relationship. The name of relationship, this side, employee side, we have learns, and then the skill side, we write learned by. So meaning that one employee can learn many skills. This one skill can be learned by one skill can be learned by many employee. Okay, and then one employee can learn many skill. Okay, one employee can learn many skills. This one skill can be learned by many employees. Okay, the last one here is employee and store, one to one. The connectivity is one to one. The name of the relationship, at the employee side we have manage, at the store side we have managed by. So one store is managed by one employee, and one employee can manage one store. Okay, next one. So far we have seen hierarchical model, network model, relational model, entity relationship model, and then we have now object-oriented model. So model for object-oriented model, it model both data and their relationship in a single structure known as object. So nama dia object dan data dengan relationship akan direpresentkan, dipersembahkan dalam object tu lah. Okay, single structure. So object-oriented data model is the basis for the object-oriented database management system. So OODMS. So OODM is said to be a semantic data model. Okay, so semantic is something related to meaning in language or logic. Okay, so this is how they represent object-oriented model. First element is object, which is an abstraction of a real world entity. Okay, so kita boleh katakan macam abstraction of a real world entity. They try to represent a real world entity in a simpler way. Okay, then attributes describe the properties of an object. Selain daripada object, dia ada attributes. So objects that share similar characteristics are grouped in classes. Okay. Then what is class actually? The collection of similar objects with shared structure and behavior organized in a class hierarchy. And then class hierarchy resembles an upside down tree in which each class has only one parent. So macam inilah contohnya dalam kelas haiwan. Okay, ada haiwan berkaki 4, ada haiwan berkaki 2. Okay, ada yang bersayap. So kelas haiwan tu dia ada bawah dia ada kelas-kelas lain lagi. So kita panggil itu adalah class hierarchy. Then class hierarchy dia macam upside down tree in which is each class has only one parent. Macam tadilah, contoh kalau haiwan, kelas yang paling atas sekali haiwan, bawah dia ada kelas lain dan bawah. Maksudnya setiap kelas tu ada satu parent sahaja. Dan contohnya macam objek. Saya bagi analogi macam kalau objek kucing, lembu, haiwan berkaki 4. So dia akan masuk dalam satu kelas yang sama sebab dia share karakteristik yang sama tu berkaki 4. Okay, dia akan ada satu kelas. Okay. Itu secara mudahnya lah. Okay. So classes are organized in a class hierarchy. Then we come to the concept of inheritance, which is the ability of an object within the class hierarchy to inherit the attributes and methods of classes above it. Okay, so inheritance ni of course lah, kalau contoh atas tadi macam haiwan berkaki, haiwan bawah dia tu haiwan berkaki 4, berkaki 2. So apa karakteristik of apa haiwan tadi, kelas haiwan tu akan diwarisi oleh kelas-kelas lain di bawah kelas haiwan tadi lah. Okay. So macam manusia jugalah, dia akan mewarisi apa daripada apa certain genetic from his or her parent. Okay, unified modeling language to describe set of diagrams and symbols to graphically model a system. So object-oriented model ni dia berkait dengan UML. Okay, so UML describe sets of diagram and symbols to graphically model a system. UML ni banyak menggunakan diagram dan simbol. Okay, next. Okay, let's look at this figure. So a comparison of object-oriented UML class diagram and ER model. So yang ni yang kita dah belajar. And then this one UML class diagram. Okay, we have relationship here. Okay, one invoice can be generated by or belongs to one customer only. Okay. Okay, yang ni invoice, how many lines. Okay. Okay, so you can see here, this is the object orientation. We have invoice. Then inside invoice, we have invoice date, the attribute invoice number, invoice ship date, invoice total, and then relationship between customer and line, which is related to the invoice. This is how the OO, object oriented model represent the object. Okay, you can see the relationship here. You can see the object, invoice, and then the relationship among customer and line. So other models, you don't have to worry. Just at this in our syllabus, you just have to know the main difference among hierarchical model, network model, among all the models. Okay, this one is a standard relational data model, ERDM, semantic data model developed in response to increasing complexity of applications. So semantic data model ni macam tadilah saya kata dia relate to something in to meaning in language or in logic. Okay, so the idea comes to explain, to model the data with respect to increasing complexity of application. Dengan bertambah kompleksnya sesuatu application tu, semantic data model ni diperkenalkan. And then DBMS based on ERDM often described as an object relational database management system, ORDBMS. So primarily geared to business applications. Okay, next one is the emerging data models. We come to the idea of big data and NoSQL. So big data. So yang ni pun sekarang ni the famous, the popular term big data, new and better ways to manage large amounts of web generated data and derive business insight from it. So nowadays data is generated everywhere, okay, and then affected almost everyone in this world. So through web, social media, and so on. And then we need for better ways to manage large amount of data. Data yang banyak tadi kita perlukan cara yang lebih systematic, better ways to manage the large amount of data generated. And then we need to provide high performance and scalability at a reasonable cost. So bila bertambahnya data, when the data grows, we need for high performance and scalability. Scalability ni maksudnya macam mana kita nak cope with the, contohnya dengan pertambahan user, macam mana you nak pertambahan data, you nak maintain the performance pada cost yang masih lagi boleh diterima. Nak proses data semua tu dengan pertambahan data yang banyak, you nak proses dalam keadaan dengan efficient dan economical. So big data characteristics, volume, the amounts of data being stored. Okay, you can imagine when we talk about social media, so how many likes, how many comments in 1 minute, in 1 second, right, generated by the people, the citizen. So velocity, not only to the speed, but also to process this data quickly in order to generate information and insight. Okay, so bila bercakap tentang velocity, it refers to the speed of data and how quickly the data can be generated and processed, okay, to derive the information and insight. Of course, bila data tu banyak, kita akan fikirkan macam mana kita nak download dengan lebih cepat ke, nak proses dengan lebih cepat ke. It is more to the velocity concept. And the variety, the data that being collected comes in multiple different data formats. So you can imagine, sebagai contoh yang paling dekat, kalau social media, so you can upload video, image, text, everything. Okay, audio, everything. So it is one kind of variety. Okay, next. Sparse data, number of attributes is very large, number of actual data instances is low. So of course lah, data tu ada banyak attribute. So big data technologies, So the first one is Hadoop, Java based. Okay, dia menggunakan language Java, open source. Open source means the code can be accessed in public and then can be modified, okay, can be enhanced and can be shared again. Okay, high speed, fault tolerant distributed storage and computational framework. Okay, yang ni bercakap tentang Hadoop, Hadoop technology. Dia high speed, fault tolerant ni maksudnya boleh tolerate dengan failure dan dia adalah storage yang secara distributed. Okay, so Hadoop distributed file system, highly distributed fault tolerant file storage system designed to manage large amount of data at high speed. So macam mana dia nak proses data yang banyak ni, yang growing data. So the Hadoop technology, we have HDFS. Dia highly distributed, maksudnya mungkin server yang menyimpan data tu bukan hanya satu tapi a few servers dalam keadaan yang distributed, not in one place. Okay. Then dia can tolerate fault. Dia adalah satu file storage system yang memang direka cipta untuk handle, okay, to manage large amount of data, maksudnya untuk proses data pada kelajuan yang sangat cepat lah. Okay. So other technologies, we have MapReduce, open source application programming interface that provide fast data analytics services. Bukan sahaja kita nak store the file, we also have to analyze the data. Okay, so we have MapReduce, yang ni untuk fast data analytics services. And then NoSQL, a large scale distributed database system that stores structured and unstructured data in efficient ways. Yang ni pun untuk storage. Okay, so let's look at a little bit about NoSQL databases. It is not based on relational model. Sebab itulah nama dia NoSQL, sebab dia bukan based on relational model. Dia tak ada relation kat situ. It support distributed database structures, provide high scalability, high availability, and fault tolerance. Okay. Support very large amount of sparse data, geared toward performance rather than transaction consistency. Dia lebih mementingkan performance lah berbanding consistency, and the data is stored in key value stores. Yang ni about NoSQL. Okay, apa maksud key value stores? So let's look at this one. Okay, a simple key value representation. So data stored using traditional relational model, and this one is data stored using key value model. Okay, kalau yang ni, in the relational model, each row represent one entity instance. Okay, yang ni yang kita go through before, previously. Each column represent one attribute. Satu column melambangkan satu attribute. Okay, contoh date of birth, I'm not sure, the license maybe, type. Okay, this is about truck. Okay, maybe the driver. Okay, how the information about this driver is stored in relational model. Okay, so driver ni dia punya his ID is 2732. So okay, let's look at this record. The first record is 2732, and then we have this one. The ID is driver ID, I think. Okay, then we have here 6 attributes. Okay, so the values in the column are the same data type. Satu column ni adalah satu data type. Okay, setiap yang ada dalam ni, setiap cell ni akan from the same data type. Okay, kalau number, kalau calendar, kalau date, semua kan. Okay, dia takkan campur lah bawah satu column tu. Okay, apa beza dengan key value model? In the key value model, each row represent one attribute or value of one entity instance. Okay, kalau yang ni, column yang represent attribute, but this one, using key value model, satu row ni akan represent one attribute or value of one entity instance. So contoh untuk driver ID 2732, key dia cert 1. Cert 1, the value is 50. And then again, for the driver ID 2732, cert 3. Okay, cert 3, 95. Okay, so you will have, since here, there are 5 attribute, and then this is the key that we use. Okay, contoh macam student, saya akan gunakan key saya untuk search apa-apa tentang student menggunakan metric number. So untuk driver ID ni, driver ID tu akan digunakan untuk search about the driver. Okay, so apa attribute lain yang dalam yang berkait dengan driver tu? Cert 1 berapa nombor dia? Mungkin driver lori ni dia perlu ambil beberapa certificate. Jadi dia ada certificate 1, certificate 3. Jadi setiap row ni akan melambangkan satu attribute, bukan lagi satu record. Ini adalah perbezaan antara data stored using key value model dengan traditional data model. So the key column could represent any entity's attribute. So maksudnya kalau driver tu kat sini ada 4 attribute, so dia akan ada 4 lah row, 4 rows here for the same driver. So the key column could represent any entity's attribute. The value in the value column could be of any data type, and therefore it is generally assigned a long string data type. Okay, so you can see here 2732 certificate 1, 2732 certificate 2, 2732 date of birth, and then 2732 maybe license identification card type P. Okay, so this is the representation for simple key value representation. Okay, this is the evolution of data models, starting with a hierarchical and then improve to network and then improve to relational and entity relationship, and then the semantic based. Okay, semantic based data model, we have object oriented and extended relational, and then big data, no SQL. Okay, so semantic in data model, you can see as we move from hierarchical to no SQL, the semantic from least go to the most one. Okay, maksudnya model yang dihasilkan tu lebih kepada it is more focused on the meaning of the data. Okay, so you can see here the explanation, the comment. Okay, so summary. As summary, each new data model capitalize on the shortcomings of the previous model. So model-model ni dihasilkan untuk menambah baik model yang sebelumnya. So common characteristics, conceptual simplicity without compromising the semantic completeness of the data. So they try to make it simple, okay, to represent the concept of the data model without compromising, maksudnya tanpa meletak ke tepi makna database lah. Okay, so they try to, in other words, we can say that it try to represent the real world as closely as possible. Walaupun dalam bentuk simple, tapi masih lagi mengekalkan meaning yang sepatutnya lah. Okay, without compromising the semantic completeness of the database. Okay, next, in brief, let's look at the advantages and disadvantages of each model. The first one is hierarchical model. The advantage is to promote data sharing. Okay, then parent-child relationship promotes conceptual simplicity and data integrity. Okay, so kalau kita tengok in hierarchical model ada parent, ada children. Okay, so dia ada integrity lah kat situ dan dia quite simple. Okay, the security is provided and enforced by DBMS untuk hierarchical model. So for hierarchical model, it is efficient with one-to-many relationships. Sebab dia konsep dia satu parent and a few children. Disadvantage of hierarchical model requires knowledge of physical data storage characteristics. Dia punya advantage, you must know. Okay, let's say satu file tu, dia parent dia yang mana. Okay, so navigational system requires knowledge of hierarchical path. Maksudnya kena tahulah bila you nak access satu data tu, you kena tahu setiap path tu sebab dia berdasarkan hierarchy. parent dia yang mana, children yang mana children, then bawah children tu ada apa lagi. So you need to know tu about the data storage characteristics and knowledge of hierarchical tree lah untuk access data. So change in structure require change in all application programs. So kalau you change, let's say you change, you bring one children to another parent, that means you already changed the structure. Okay, then you have to change all the structure in all application program. Okay, maksudnya kalau satu file tu sebelum ni you letak bawah parent yang ni, you bawa you tukar parent dia, jadi cara you nak access that data also change. And then of course it will cause implementation limitation. Okay, no data definition and lack of standard. Tidak ada standard khusus lah untuk hierarchical. And then the network model, conceptual simplicity, handles more relationship types. Okay, yang ni as we have seen, one child can have more than one parent. So data access is flexible. So data owner member relationship promotes data integrity, conformance to standard, and also they include data definition language, DDL and DML. Okay, this one we are going to see in our lab session here. What are DDL and DML? So the disadvantage of network model is system complexity limit efficiency. Of course, bila satu child tu has more than one parent, it is quite complex, and the navigational system yields complex implementation, application development, and management. And then structural change also require change in all application programs. So sebab dia melibatkan parent dengan child tadi. So once you change the structure, you have to change also all application programs. And then for relational model, structural independence is promoted using independent tables. Yang ni dia lebih structural independence, maksudnya even you change the structure of the file, it doesn't matter. It doesn't affect the way you assess the data. Okay, remember I have explained to you that data independence before this. So tabular view improve conceptual simplicity, quite simple. Ad hoc query capability is based on SQL, dan dia menggunakan SQL untuk kita buat untuk kita derive query. Isolate the end user from physical level details, so the user does not need to know the physical details. Okay, improve implementation and management simplicity. The disadvantage is requires substantial hardware and software overhead. Conceptual simplicity give untrained people the tools to use a good system poorly. May promote information problems. And then we come to ER model. Visual modeling yields complex conceptual simplicity. Okay, so bila kita consider ER model, mudahlah untuk kita tengok apa entity, apa relationship, one to many ke apa. So visual representation makes it an effective communication tool. So you boleh use that visual tool for effective communication. Is integrated with the dominant relational model. Disadvantage, limited constraint representation. Okay, kita tidak ada constraint dekat visual tu. And then limited relationship representation also. No data manipulation language. And loss of information content occurs when attributes are removed from entities to avoid crowded displays. Of course lah, dekat ER model tu kita tak senaraikan attribute, kita cuma ada entity dengan relationship sahaja. And then what about object-oriented model? So for object-oriented model, semantic content is added. Visual representation includes semantic content, and inheritance promote data integrity. The disadvantage, slow development of standard. Tidak ada standard, lambatlah dia punya perkembangan untuk standard tu. Cause vendors to supply their own enhancement, compromise widely accepted standard dari segi standard. And it has complex navigational system. The learning curve is steep, okay, and high system overheads post transaction. And then no SQL, the next one. Advantage, high scalability, availability, and fault tolerance provided. Use low cost commodity hardware and support big data. So the key value model improve storage efficiency. Macam tadi kita tengok setiap attribute ada row yang berbeza walaupun bagi entity yang sama. Maksudnya tidak perlu, kalau kita bandingkan tadi key value model dengan relational model. Kalau relational model, bila tidak ada value untuk satu-satu, okay, let's look. Okay, bila tidak ada value untuk satu-satu attribute tu, cell tu akan kosong. But when you use key value model, so every cell will be occupied. Okay, disadvantage of NoSQL complex programming is required no relationship support, no transaction integrity. In terms of data consistency, it provides an eventually consistent model. Okay, next, let's look at degrees of data abstraction. Okay, this a way of classifying data models. Many processes begin at high level of abstraction and proceed to an ever-increasing level of detail. High level of abstraction ni maksudnya dia dalam bentuk yang simple. Okay, simple representation. Okay, the idea is presented in a simple representation. Itu maksudnya high level abstraction. Okay, dan pada peringkat yang atas tu dia high level of abstraction and proceed to an increasing level of detail. Kemudian barulah dia narrow down secara detail. So designing a usable database follows the same basic process. So American National Standard Institute, Standard Planning and Requirement Committees define a framework for data modeling based on degrees of data abstraction. Okay, so NC dengan Spark ni dia define satu rangka untuk data modeling process based on degree of abstraction in 1970s. So 3 degrees of abstraction are external, conceptual and internal. So apakah itu external, conceptual and internal ni? Okay, let's look at the data abstraction level. Maksudnya from end user view. Okay, this is end user view. So when we talk about database, kita bercakap tentang end user. Akhirnya peringkat yang paling atas sekali end user. So end user is related to external model. Okay, so external model is connected to conceptual model. So end user dia akan nampak external model sahaja. Kemudian designer's view, dia akan nampak conceptual model. And then kemudian internal model is the view of DBMS and then physical model. So you can see from this table degree of abstraction and its characteristic. Okay, so high abstraction, the characteristic is high abstraction refers to hardware independent and software independent. Okay, when the degree of abstraction is medium, okay, same, hardware independent, software dependent. Okay, maksudnya pada peringkat yang kalau high level of abstraction, it is the hardware independent. Maksudnya dia tidak bergantung kepada hardware dan tidak bergantung kepada software. Okay, dia just representation dalam bentuk yang paling high level abstraction. Maksudnya data model tu dia represent dalam bentuk yang paling simple. Jadi dia tidak bergantung kepada sebarang hardware ataupun software. So, and then when we move to the second degree, the medium degree of abstraction, it does not depend on hardware independent, but it depends on software. Okay, then when we go down to low degree of abstraction, it depends on both hardware and software. Okay, so you boleh nampak kat tepi ni, di peringkat medium, medium ni adalah internal model. Okay, yang low degree of abstraction ni adalah physical model, yang high degree of abstraction ni conceptual model dengan external model ni lah. Okay. So semakin dia bergerak ke atas, okay, semakin tinggi level, degree of abstraction. So end user hanya melihat tu dalam bentuk yang paling simple representation. Okay. So bila satu-satu data model tu dia depends on hardware, dia depends on software. So kita panggil logical independence. Okay, yang ni yang ni adalah logical independence dan yang ini adalah physical independence. Okay, setakat ni. Okay. So kalau you tengok dari bawah sekali, dia akan bergantung kepada kedua-dua hardware dan software. Kalau yang medium ni dia hanya bergantung kepada software but not hardware. And then yang atas sekali ni memang independence of both hardware and software. So dari segi modelnya, ER model is hardware independent and software independent. And then when we talk about relational and object-oriented model, it depends on software but it is hardware independent. And then for network model and hierarchical model, depends on both hardware and software. Yang tadilah yang kita sebut bila kita mengubah path of the data, the way we assess the data also will change. Okay, untuk network dengan hierarchical. Okay, so let's look at one by one. The external model, end user's view of the data environment. External model ni adalah macam mana user, pengguna akhir ni melihat data tu secara keseluruhannya. So requires that the modeler subdivide set of requirements and constraints into functional modules that can be examined within the framework of their external models. So external schema. External schema is specific representation of an external view. External view ataupun user view tadi, dia boleh direpresentkan dalam bentuk yang spesifik, which is known as external schema. So the ER diagrams are used to represent the external view. So user view ni dia menggunakan ER diagram. So it requires that the modeler subdivide set of requirements and constraints into functional modules that can be examined within the framework of their external model. So user akan menggunakan ER diagram, okay, to subdivide set of requirement. Okay, apa kehendak dia, apa constraint yang ada ke dalam bentuk functional module yang boleh disemak dalam framework external. So advantage, easy to identify specific data required to support each business unit's operation. So bila you nak bina satu database, you akan make interview with the end user. So end user akan guna ER tadi untuk represent dia punya external view. Okay. Apa constraint dalam dia punya organisation. Okay. What are the data required to support business operation. So this kind of external model facilitate designer's job by providing feedback about the model's adequacy. Creation of external model helps to ensure security constraint in the database design and simplifies application program development. Okay, so let's look at how does it look for external model of tiny college. Okay, so user akan, katalah you nak bina satu database untuk college, so kita akan ada apa, student registration, class scheduling. Tu yang penting bagi user. Untuk college ni yang penting student mesti register, lepas tu mesti ada class scheduling. So dalam tu apa, dia punya role dia. Ini adalah satu contoh external model. A student may take up to 6 classes per registration. Okay, so ada entity student, ada kelas. Satu student boleh ambil banyak kelas. Satu kelas can be enrolled by many students. Okay, so one to many, dia punya relationship sebenarnya many to many. But when we have many to many relationship, kita akan pecahkan kepada one to many dan kita akan create satu lagi entity. Okay, but you don't have to worry. This one we are going to learn in the next chapter. Okay, And then one course can generate many classes. One class is for one course. Okay, ini adalah constraint yang dia adalah a class is limited to 35 student. So class scheduling pun sama. A room may be used to teach many classes. Each class is taught by in only one room. Okay, satu kelas of course dia dalam satu bilik darjah. So, and each class is taught by one professor. Okay. So kita assume satu kelas satu professor and a professor may teach up to 3 classes. So daripada external model tadi kita boleh nampak dia sebagai satu cara untuk membantu designer. Okay. Dan satu lagi dia akan ada to identify the business unit operation, nak kelas schedule ke, nak kelas registration ke. Okay. Dan user pun bagaimana cara user melihat tu kita akan boleh nampak melalui external schema ni lah. This one is known as external schema. Okay, next one is conceptual model. Conceptual model ni dah okay. This one, you refer to this one. This one is designer's view. External model is end user view. Okay, so for designer's view, it represents global view of the entire database by the entire organization. Ni adalah programmer's designer's view. So we know it is known as conceptual schema. So untuk conceptual model, kita panggil conceptual schema. Basis for identification and high-level description of the main data objects. So logical design, task of creating a conceptual data model. Most widely used conceptual model is the ER model. So yang paling banyak digunakan ialah ER model. Okay, this is the conceptual model. So student, kalau tadi yang end user, dia akan tulis dalam bentuk statement macam ni. Okay, so it is the task or the job of the designer to double check this one. Okay. Okay, so one student may take up to 6 classes per registration. So one to many. Okay, this one class can be taken by many student. Okay, one class can have many class. Okay, contohnya ICT450 ada banyak group. Okay, banyak kelas lah. Tapi satu, let's say your group, apa contohnya group 249, group berapa, ataupun 241, A ke B ke C, tu satu kelas untuk ICT450, maksudnya untuk satu course tu je lah. Okay, so is used, satu kelas is used for, one room is used for many classes. Okay, one class use one room only. Contoh ICT450 untuk group 3A. Maksudnya untuk kelas tu ICT450 group 3A akan guna satu bilik tu je lah. Okay. Then satu professor can teach many classes. One class is teach by by one professor only. Maksudnya satu subjek tu satu pensyarah je mengajar. Okay, kita tolak tepi lah yang sharing tu. Okay. Okay, still about conceptual model, provide a relatively easily understood macro level of data environment, independent of both software and hardware. Of course lah, dia tidak melibatkan software ataupun hardware. Okay, does not depend on DBMS software to implement the model. Tidak perlu pada DBMS software and does not depend on the hardware used in the implementation of the model. Change in either the hardware or DBMS software have no effect on the database design at the conceptual level. So kalau kita tukar nak guna IBM DB2 ke, nak guna Microsoft Access ke, dia tidak mengubah ER diagram yang kita dah bina. Okay. Next one is internal model. Representation of the database as seen by the DBMS maps the conceptual model to the DBMS. Ini kita panggil internal schema. Internal schema depicts a specific representation of an internal model. It is software dependent and hardware independent. So logical independence, changing internal model without affecting the conceptual model. Okay, maksudnya dia tidak, maksudnya kalau kita ubah internal model tu, dia tidak mengubah pun conceptual model yang atas tadi. Okay, this is the internal model as seen by the DBMS. So conceptual modelnya, one professor teach many classes, one class can be taught by one professor only. So internal model dia, inilah segala command, coding ni semua adalah internal model. Of course dia akan berkait dengan software, tapi tidak berkait dengan hardware. Okay. So kalau you change the command or whatsoever, it does not affect the conceptual model. And the last one is physical model, operates at lowest level of abstraction, describing the way data are saved on storage media such as disk or tape. Of course, bila dia describe the way data are saved, semua tu dia akan melibatkan software and hardware dependent lah. Okay, requires that database designer have a detailed knowledge of the hardware and software to implement database design. And it is when we talk about physical independence, change in physical model do not affect the internal model. Maksudnya cara you simpan data dekat storage media tidak akan effect internal model yang you dah buat tadi. Okay, yang ni command-command yang you buat tu tidak berkait pun dengan kat mana data tu disimpan dalam storage disk ke ataupun tapes. Okay. So we come to this summary. Okay, external model very high level of abstraction, and as you move from external conceptual internal physical, dekat physical ni you can see that it has the low degree of abstraction. Okay, so very dependent on hardware and software. Kalau external dia kalau internal model dia bergantung kepada software, conceptual, hardware and software. Yang ni pun sama, external, hardware and software. Okay, untuk internal specific database model, physical storage and access method, conceptual global view of data, independent of database model. So finally, as a conclusion, data model is a relatively simple abstraction of a complex real-world data environment. So data model ni diperlukan untuk kita represent dalam bentuk yang simple. Okay. Yang mana real-world data environment di sekeliling kita ni sangat kompleks. Jadi kita perlukan data model untuk kita represent tentang data ni dalam bentuk yang simple. So you can see here hierarchical model, dia one to many, network model pun one to many, and you can see about relational model yang ni just summary, you can go on yourself. Okay, so I think that's all for today.